Hey everyone, welcome to this video lesson. In this lesson, you'll learn how to simplify rational expressions. So the plan is for step 1, factor numerator and denominator completely. Step 2, you're going to cancel the matching factors. So simplify, state any restrictions on the variables, and restrictions means we have vertical asymptotes at these x values when you sketch the graph. Center from quadratic, you have ax squared plus bx plus c. In this case, the value of a is 1, the value of b is negative 2, and the value of c is negative 3. So what we need to find is multiples of negative 3 that when we add them give us negative 2. And since 3 is prime, the only multiples are x and 1 and x and 3. But then we have to think, okay, I need a negative 2 when we add them. So that means the x gets a minus and the 1 gets a plus, because 1 minus 3 is negative 2, and 1 times negative 3 is negative 3. Now, denominator, multiples of 4 that add to 5. Okay, so for this one, the only multiples for that add to 5 are 1 and 4. So then this will be plus, and this will be plus also. So as you can see, these are the matching factors x plus 1 and x plus 1. So then this simplifies to x minus 3 over x plus 4. But then here come the restrictions. Okay, we cannot just leave this problem like this. We have to state which values of x we cannot use because we have asymptotes at those points or those values. So then restrictions are x cannot be equal to, for this one here, negative 1, and the other is negative 4. So there you have the answer to this problem along with restrictions. For example number 2, for this one we need to find multiples of 12 that when you add them give you a 4. So the only multiples are 6 and 2, right? So then 6 and 2, but we need a negative 12 when we add them, we multiply them, and 4 when we add them. So that means the 2 gets the minus and the 6 gets the plus, because 6 times negative 2 is negative 12. 6 minus 2 is 4. So that's the numerator. Now let's do the denominator. So now we need to find multiples of negative 6, and when we add them give us a positive 3. So this should be x and 3 and x and 2. So we need a positive 1, so then x minus 2, and this is x plus 3. From here we should be able to see the matching factors. So this one and this one we can cross out and then simplify. So then this simplifies to x plus 6 over x plus 3. But now the restrictions, x cannot be equal to negative 3 and positive 2. So there we have the answer to this problem. Okay, next example. So for this one, at first we don't see that anything simplifies, but don't forget that there's always possibly a GCF. So this is 3x, and there's a GCF of 3x between 3x squared minus 9x, so I'm going to factor it out. So then this now becomes x minus 3. As you can see, this one and this one simplify, but be careful here. This becomes a 1 and this becomes a 1. But if you multiply 1 times x minus 3, you still get x minus 3. So the answer to this one is 1 over x minus 3. But then restrictions for this one. For 3x, x cannot be equal to 0, okay? Because if we allow x to be 0, then everything here becomes 0, which will make it undefined. So there's an asymptote at x equals 0. For this one, x cannot be equal to positive 3. So there we have the restrictions along with the answer to this problem. Okay, so that's example number 3. Example number 4, numerator has a GCF of 3. So I'm going to factor it out, and then this becomes x squared minus 9 over x plus 3. But this one here is the difference of squares, so I can factor out this one further. So we have 3 times x minus 3 times x plus 3 over x plus 3. And now, as you can see, those matching factors cancel out, or you can cross them out. So then what's left is 3 times x minus 3, because this becomes a 1, and 3x minus 3 times x minus 3 over 1 is the same as 3 times x minus 3. So now restriction, there's only one, and that is that x cannot be equal to negative 3, because I will make this undefined. Okay, so this is the answer to example number 4. Example number 5. For this one here, since a is not equal to 1, when I say a, I mean this a value, this is equal to 3. So then this one we do by grouping. So don't forget how to factor by grouping, and then we'll see what we can cross out or cancel out. So multiples of negative 4, multiples of 3 times negative 4, which is negative 12, that when we add them, give us a positive 1. So multiples of negative 12, that when we add those multiples, they give us a positive 1, which is our b value. And those multiples are, let's see, so this would be negative 3 times 4, because negative 3 times 4 is negative 12, negative 3 plus 4 is 1, right? So which is the b value. So then I have 3x squared minus 3x plus 4x minus 4. So from these two terms, I can factor out a GCF of 3x. And then we have x minus 1. Okay, and from these two terms, I can factor out a 4 as a GCF. So plus 4 times x minus 1. Then I can put together 3x plus 4 and x minus 1. I can factor out because they have it in common. So x minus 1 times 3x plus 4. So then the denominator factors out as, this one stays the same, 3x plus 4. Denominator is x minus 1 times 3x plus 4. And as you can see, we have these two matching, so we can cross them out, those factors. So then this simplifies, so don't forget this becomes a 1. Okay, this here becomes a 1. So then we have 1 over x minus 1. So this is the answer, but along we need to state the restrictions. So for this one, x cannot be equal to positive 1. And for 3x plus 4, okay, so for this one, if you set this equal to 0, so 3x plus 4, which is a linear equation, you subtract 4. So then this becomes 3x equals negative 4. Then you divide by 3, which means that x cannot be equal to negative 4/3. So negative 4 over 3. So there is the answer along with the restrictions for this problem. Okay, I'll see you in class. Thank you for watching. Bye-bye.